Week 5 of C++, Intro to C++. We're going to do a quick recap from last week, and everybody is pretty on it right now. I asked what it was before I showed the slide, and vectors and arrays was the main concept that we covered last week in class, so you guys are correct. We also covered a couple other things before vectors and arrays, including the C math library, which gives you access to these 5 functions: square root, power, round, floor, and ceiling. And then we also talked about the cstd_lib, which gives you access for the rand and srand function. So if you want to generate a random number for rolling a dice or something. We also talked about including the time preprocessor directive, which is what we use to seed our random number generator. And I included an example of the code right here, calling the srand function and then the elapsed seconds time null pointer that we pass into that function to generate that random number. And then what we did was we rolled a dice, modulus 6, and then added 1 because it was from 0 to 6. And so then we were increasing it from, or 0 to 5, so then we made it 1 to 6. Cool. We also discussed the cin.ignore method or function that discards the extra new line character in the buffer. So when you enter numbers as a user into command prompt and you do like 1, 2, 3, 4, after that there's a /n in the buffer. So sometimes there's a problem when reading strings from the user, and it will just read that new line as the next thing that was put in the buffer. So if you're asking for 2 things, sometimes it'll read that /n as the second argument passed, when really we should do cin.ignore to discard that extra /n and then read the second argument. And then you guys are correct. We talked about arrays and vectors, an example of how to initialize an array here. And remember, arrays we have to set to the actual number of elements, or we can just leave the square brackets empty and then fill it, and it will automatically know that there's 5 letters in the A-E-I-O-U example. And then with vectors, move that image down there a bit. We talked about how to initialize them and how they actually have bounds checking, which is better than arrays, and they dynamically grow or shrink using the pushback element. They also come with some other methods, I should say methods, not element. Using the pushback method or the .at method provides bounds checking. There's also .clear and .size, which we can get the size of the vector dynamically. But remember, you have to include the vector preprocessor directive when we do vectors. And there's just a little example of how to initialize a vector. We also discussed multidimensional arrays, multidimensional vectors. So you guys were working on making a multidimensional vector of vectors. So hopefully that's going okay. I haven't gotten any emails or questions about it, so I'm assuming you guys all know what's going on with that. But again, really quickly to talk about multidimensional arrays and vectors, the first column, or square brackets, I should say, is the rows, and the second square brackets is the columns. So we can see here the rows goes down like this. So we have 1, 2, 3, and then we have 4 in our second one, 1, 2, 3, 4, going across like that. And that's just an easy way to visualize 2-dimensional arrays. Very good. Okay, so if we open up Blackboard, I've got another weekly recap test here that I want to go through with you guys, and the password should be in the description of the test. So if you click that link, I put a time limit of 25 minutes on the test, and we can begin that now. And oh, if I just cancel out of here, the test password was in there. Does anyone see the test password? I think if you go to assignments and tests, it's right here. 4th week test. There we go. Thanks, Jillian. So that's also how you can access the test. Cool. All right. So let's just open this up and begin. Put our password in there. Awesome. All right. So I'm going to let you guys try to do this as much as possible without helping you. Arrays are always indexed starting at subscript blank. Begin, 1, start, or 0. Jillian said 0, and then she said, oh. Radhan says 0. Does anyone else disagree? Or do we all think 0? Yes. Okay. I agree with you guys. We'll go with 0. Nicely done. How many integers can the array named numbers in this example contain? 9, 10, 11, or none? So if we're starting at a 0 index, how many how many integers can the array named numbers contain? So we're starting at a 0 index. Julian says 11. Mila says 11. Hung says 11. Fatima says 9. Rashmeet says 11. Okay, we're getting a bit of a discrepancy here. Hung says 0 to 10. Okay, so that would be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simon says 10. And Radhin says 10. Okay, so you guys are a little bit divided. This is the first time we've had a question like this. Fatima's now changing her mind to 11. It's 10. So because we're declaring it as 10, right? So it would hold 0 to 9. It would hold 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, Raymond's got it right there. And that's 10 integers, 10 fingers that I'm holding up. The answer's got you unsure of yourself. That's okay. That's why we do this. So the number that we declare here is the number of elements it holds. Just because it's 0 index doesn't make that one more or one less. So it'll always be 10. Um, no. Like it can still hold. So the array, yeah, integers begin at 1. It doesn't matter what the values are, though, Fatima. The indexing, though, would still begin at 0 for this. So you'd begin at 0, and you'd have your 0 element, your 1 element, your second element, your third element, your fourth element, all the way up to your ninth element, but that's actually 10. So if I go back to my PowerPoint here, we can see here they made um, an array. Now they're not using the square brackets, they're using the curly brackets, but they made an array with 4. And we can see if we count these green numbers 0, 1, 2, 3, that's still 4. 0, 1, 2, 3, right? So same example, if we just do 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's actually 10. I know it's super confusing, and like once you actually get that, then you know, it'll just click kind of thing. But that can be confusing at the very beginning, and lots of errors can happen because when you want to get an element, you actually have to get the element -1 to get the actual position that you're looking for. Yeah, it is a little bit weird like that. No worries. That's all good. Good catch on that, guys. You guys who got that correct. Okay, which of the following is a legal array definition in C++? Real numbers 5. Simon says he's never heard of type real. You would be correct. Double 5 numbers 5. Int numbers 0. Float numbers 10. What are we thinking? So he's never heard of type real. So I think we can let me zoom in on this just so you guys can see it a little bit better. I think we can rule the first one out here. It might be in a separate order for you guys, so it might not be in the same order, but real numbers -5 or square brackets 5, I think we can rule that out because we know that there's no type of real. Double, int, and float are all valid types, so okay, we can deduce even further. Can we make an array when we use our naming for an array or for variables? Do we ever include numbers in our naming convention? Radhen says maybe D. You think because the array would try to stop short of 0, int numbers 0 wouldn't work? Oh, you're still going back to the. Oh no, sorry, that is for this question. You think because the array would try to stop short of 0, int numbers 0 wouldn't work. So you're onto something there, Jillian. So looking at number C here, if I just annotate just so everyone's looking at the same spot here. Sheesh, my annotation's a little bit broken. I annotate, my screen just goes black here. And can you guys still see my screen? Gosh, I can draw, but I can draw, but it just goes black. Maybe this time, third time's the charm. There we go. So this is the one Jillian's talking about. You guys should be able to see my screen now. So it's int numbers 0, and we can't actually have an array and declare it with 0 elements in it. So that's actually incorrect too. So we know that type real doesn't exist. We know that numbers 0 should at least be greater than 0. So we can't have that. And then we never actually declare a name for something with a number in it, like 5 numbers like this, with the number 5 in it. So we also can cross that out. So by deduction, it should be float numbers 10, which is a lot of what you guys are saying in chat. So that's good. Cool. All right. C++ treats an array name as a variable, the first array element, the location in memory of the first array element, all of the array elements. Location in memory is what Jillian thinks. Not entirely sure though. What else are you thinking? All of the array elements? C++ treats an array name as, so remember last week we did a little example where we did a C out, and then we just typed the name of the array. So we didn't do an array with the square bracket array syntax with the number of the index we wanted to print. We just printed the array name. And remember, it returned something to us that looked like 101476 times 10 to the power of negative 370. And that number represents something. That's right. Okay, good. So there we go. That triggered something from what we did last week, Raymond. It's a location in memory is what he's saying, because it gives you a slot of memory or the location of memory. Perfect. Cool. So you guys are kind of getting there. Just a little bit of a reminder. So yes, when we printed that name and it gave us like all those weird gibberish numbers, that's basically the memory address or the address in the memory of where that variable or array is stored. And then it uses math and adds the bytes, depending on the size of what type of array it is, to get the next elements in the array. So if you have an int and it's 8 bytes, then it just adds 8 bytes to that memory address. That's right. So you guys got it. Location in memory of the first array element. Not a string, but like the index key of the memory. Yep, just the location of the memory. You got it. Cool. Good job, guys. All array elements must be enclosed in square brackets, constants of the same type, literals. So we can make an array of constants. Remember, we looked that up last week, but then you wouldn't be able to change them. And I don't think that it's necessarily fundamental that every single time you make an array, there have to be constants or literals. So we can rule those two out. Okay, everyone's saying the same type. Yep, you guys got it. Everything has to be the same type. So if you're making an array of ints, they all have to be ints. If you're making an array of chars, they all have to be chars. So that's right. Okay. Given the following array declaration, how would you display 100.7 from the array? So here's our array declaration. We've got double temperatures, and then we're leaving the square brackets empty, so we're letting the compiler automatically decide the size of the array, equal to, and then we're initializing it in our list initialization with 5 different elements. So our first one's 98.6, 95.2, 88.7, 100.7, 89.0. So we've got we've got 5 different elements. What would we do? You guys think it's C, the third option, temps 3 or temperatures 3? Hung says temp 3, Raymond says temperatures 3, C out temperatures 3 and line. Oh, we changed it. Yes, so if we take a double quick look at the name of the array, we can see it's temperatures, not temps. But the third index is the correct index here because, like we were just saying earlier, and sometimes we can easily forget this. Sheesh, my screen just going black when I try to draw. Oh, let me try one more time. Array indexes start at 0. Okay. So this one would be 0, 1, 2, 3. You guys got it. Okay. Good. Oh, you can see? For some reason, my screen goes black, so I can't draw, unfortunately. So I just look crazy. Question 7. Given the following array declaration, what would the following code display? So we've got an array called double temperatures, and we're leaving the square brackets empty, and then we filled it with the same values 98.6, 95.2, 88.7, 107, and 89. So it's double temperatures. And then we try to do cout temperatures 5, which would actually be at the 6th element because we've got our 0 index, 1, 2, 3, 4. So there is no 5. So will it generate an out of range error? 89, which is actually the 4th element, so that would you'd have to put number 4 in. It won't compile or garbage data. Jillian says array out of bounds exception. Radin says an out of range error, out of range error. Now, here's a quick question for you guys. Let's see if I can annotate. Ah, I can this time. Okay. Hoorah says garbage data and Simon says garbage data. Okay, so it looks like it's between this option and this option. Now, remember, this is an array declaration, not a vector. And vectors give us bounds checking, but they only give us bounds checking when we use the dot at method and pass it the number that we want to get. So in this case, 5, right? You remember you were asking this stuff and you were surprised with the answer. That's right, Pura. Yes, so you are remembering. So it would be garbage data because it's a array, don't give us out of range errors. An array doesn't give us this. Only vectors with the dot at. You can still have a vector, right? And you can still use array syntax to get an element like this. And if you use array syntax, and what I mean by array syntax is I mean this and this, the square brackets. If you use array syntax, you will not get the out of range error. You will only get the out of range error if you use the dot at method. Does that make sense? I'm drawing everywhere here. And same thing, arrays only use array syntax, which is the square brackets, which means we do not get out of bounds checking. So it would be garbage data in this case. Cool. Awesome. How would you define a vector named temperatures that contains doubles? All right, so we've got a couple examples here. We've got vector double temperatures, vector square brackets double temperatures, double vector temperatures, and vector angle brackets double temperatures. I may have just given this one to you with my drawing, if you guys are paying attention. Mila and Fatima say D, which is vector angle brackets double temperatures. Simon also agrees. Yep. So we use the angle brackets to do vectors. That's correct. Nice. Question 9. How would you determine the number of elements contained in a vector named temperatures? Okay, so same vector that we just created named temperatures. Do we use the temperatures.size method? Do we use temperatures.num underscore elements? Do we use temperatures.num underscore elements? Two of them are the exact same. Or do we use length, the length method with temperatures? Yeah, correct. We use temperatures.size. Everyone's on that same page there. Yeah, the dot size method is what's declared in the vector class. Correct. Okay. And what is one way that vectors and arrays are different? Vectors can vary their capacity as the program runs, but arrays are fixed in size. Arrays can only store primitive types. Vectors are always more efficient than arrays. Vector elements cannot be accessed using their subscript. Subscript, again, is those square brackets, right? What do we think? Again, people are thinking option A, which is vectors can vary their capacity, which means their size, as the program runs, but arrays are fixed in size. Yeah, okay, cool. Everyone's on the same page with that. A, option A, that's true. Cool. Question 11. In order to use the square root function, where we pass it a number, what header must we hashtag include in our preprocessor directive? We've got cmath, we've got square root, we've got cstlib, and we've got vector. Cmath, option A, yes, cool. Square root is a math function, so we use the cmath library. Nice. In order to generate random numbers in C++, we must use the cstd-lib preprocessor directive and the what preprocessor directive to seed the srand function. We have srand, c null pointer, c time, elapsed underscore seconds. We need two libraries if we want to make random numbers, like a dice roll or something like that. We need one library, which is the cstd-lib, which includes the srand and rand function. And then we need to seed, or actually propagate that seed, with another method from another library or another preprocessor directive. And we use seconds to do that. Jillian's thinking either ctime or srand. Simon says ctime. Jillian says srand. So we want to use seconds to actually implement our seed function. So if I look back at the PowerPoint here, we can see here we've got, we're using time method to get an int value. And so we store it in a variable called elapsed seconds. And then we're using the time method and passing in a null pointer. Then what we do is we pass that variable of seconds into our srand, and we include the time preprocessor directive. In order to use the time function, we include the time preprocessor directive. And I'm actually incorrect here. It's just time, not ctime. So I'll have to fix that, but it is ctime will give you the correct answer, but to be technically correct, the C should not be there. So that's my bad. Cool. Question 13. How do we fix the problem with reading strings when there's an extra /n or new line character left in the buffer? cin.ignore, cout/n, cout end line, or get line cin var. Bura says ignore. Rashmeet says A, which is also the ignore. Jillian says ignore. Sounds like everyone is agreeing on this. Does anyone think it's something else? Or do we all concur that it's cin.ignore? Fatima agrees. Nice. Cool. Yep, that would be correct. We can just double check that on our PowerPoint here. cin.ignore discards the extra new line in the buffer. So that is pretty clear right there. Usually my review slides have all of the information you need for these quizzes, just so you guys know. To use vectors, we need an preprocessor directive, a hashtag include vector in our preprocessor directive. Jillian says true, so it's a true or false question. Do we need to include vector if we want to use vectors in our program? Yep, true. Lots of people agreeing on that, must be true. Nice, very good guys. Okay, cool. And last but not least, this question is vectors. It's another true, false. Vectors only provide bounds checking if you use the .at method. So remember, we can use two ways to access vector elements or indexes. You can use the subscript notation, which would be this, okay? Or we can use the .at method. Which way provides bounds checking? Yes, we just covered this. It's true. Good. Just wanted to nail that home just so you guys understand. Okay, cool. Save and submit. That's all the questions, 15 questions. And 20 minutes. Cool. And it should have been perfect. Very good. Awesome, guys. Great work. I'm going to stop sharing the screen recording right now so that this can be a separate video on its own, and then we will pick up the recording again when I get into the next PowerPoint.